Capital is abundant. Understanding is scarce. The Dynamo Show goes deep with the new industrialists rejuvenating industry and commerce. Brought to you by Dynamo Ventures. Learn more at dynamo.vc/podcast. Now, here's your host, Madelyn O'Farrell.
Welcome back. I'm your host, Madelyn O'Farrell, and today we're joined by Juan Aparicio. Juan, thank you so much for being here.
Thank you. It's a pleasure to be with you.
Juan, I know you're the co-founder and CEO of Reshape Automation. I thought we would start there. Could you give us a little background on what it is you're building?
Yes. So, as you said, our name is Reshape Automation. Our main product, Reshape X, which is a series of AI agents developed exclusively for industrial companies. We help these industrial companies design, build, deploy, and operate AI agents for their teams and customers. Sometimes they use it internally. Sometimes they put it on their websites to help their customers. And this is applied mainly to their sales and technical support processes, but we are also moving more and more into their operations. And they can automate a big part of these processes and save sometimes hundreds or millions of dollars in some cases just by automating the tasks that these agents now are taking. And I think we are going to deep dive during the podcast on what makes us unique. But just as a hint, obviously with an AI agent, there is a layer of LLMs that really enable our business. We couldn't do this 5 years ago. But there is also a lot of curation, logic, and hard work behind every single agent to make sure it performs well 99.9% of the time.
How much time is involved with that implementation and deployment of the agents then, given some of that customization work that you're doing?
Yes, that's because we handle everything, right? From the design, gathering the data, and making sure that the logic works. And there is tight integration also with the customer workflows and their tools that they use. Typically, it takes us 4 to 6 weeks. Some deployments, the more complicated ones, where we have to handle also connections to custom databases, it may even go up to a couple of months. But that's our average, between 4 to 6 weeks of full work, working together with the customer, with our AI solutions engineers or forward deployed engineers. I think now is a term that is broadly used to make sure that the agent performs as they want. And then it goes live and the work doesn't stop there. Like, we make sure that we continue learning, getting the feedback, and incorporating that into the agent. So over time, we see it improving continuously. We do technical reviews almost weekly with our customers, and then business reviews quarterly. So we also ensure that every quarter we look at the KPIs and say, okay, you put this agent in your website. Are you getting more visitors? Is the retention higher? Is your CSAT also higher? All of these things we monitor to make sure, because it's a subscription, right? So if we are not moving the needle, then they can stop and then move on, right? So it's very important for us that we always deliver up to the expectations.
Amazing. And before we dive deeper into the nitty gritty, can we start with your story? What's your background and how did you get into this space?
Yes. Okay. I will try to make it not super long. So as you can tell, the accent it sounds like, I don't know, Rafa Nadal. So it comes from Spain. That's where I grew up. Studied telecommunications and computer science in Spain and Sweden. And at some point, I graduated, I think, in the middle of this crisis in 2008, 2010. And during that time, my plan was, okay, let's find a job in Sweden. But I found a little advertisement from a company called Siemens, right? Another small startup, 170-year-old or more. And they were, it was for an internship in Princeton, in New Jersey. I didn't know a lot about Siemens. I thought they were doing phones at some time. So I applied, and it actually, like, my dissertation was exactly what they were looking for. I ended up in the US, and what was supposed to be 6 months is now 15 years. And I am now an American with American kids. staying for long in this country. But Siemens was the company that brought me to the US. It's an incredible company. I grew with them. So I said my first project was actually on autonomous and connected cars back in 2010. Well, like that was really the starting of autonomous cars. And too early, I think Siemens, we were too early for that kind of technology. And then started to get more familiar into robotics and automation. That is the bread and butter, particularly industrial automation is the bread and butter for Siemens. And I fell in love with robots, basically. It's, when you think about telecommunications like 4G, 5G, there is very little increments. Obviously, every time that there is a new technology, we eat all the bandwidth as customers. But that seems like a very mature and only doing optimizations. When you go to industrial automation, the sky is the limit. Like we are still moving memory tags from one device to another, and that's how we communicate. There is very little flexibility. AI was not making any strides there. So fell in love with that. At some point, my call to fame in Siemens was designing this factory of the future back in 2014. And that is funny because to see some of the technologies like AMRs, connectivity, autonomy that we were working then, now they are mainstream. And then 2015, Siemens, big German company, again, incredible company. They had some footprint in Silicon Valley, but it was limited to this, what is now Next 47, what used to be Technology to Business, TTB, that was helping the bridging the gap between startups and the business. But they decided, okay, we need to add more engineers. And we are Siemens. We are going to tell Silicon Valley what to do. That didn't work, as you can tell. So it was expensive. A lot of business didn't end up committing. So 1 year after, they have a very small group and they send me here, okay, do whatever you can kind of with that group. And at some point, it was just me and one of my employees, Chen Tao, an amazing engineer. But then after a few years, we were one of the most successful research groups at Siemens. And I think our key was really working elbow to elbow, very close with Stanford and Berkeley, professors over there, publishing together, focusing on one question that was really back in 2016, is deep learning going to revolutionize robotics? So my journey brought me to a lot of conversations with professors trying to convince them that AI had a better home in factories and warehouses than in autonomous cars, because autonomous cars was the big hype back then that was funding all the research. And some of these companies now people like Ken Goldberg or Peter Avil or Sergey Levin, they all have their own startups in this realm. But back then, it wasn't that clear that manufacturing was or logistics was the right place. Then I started working also with the government, advising them in different capacities. That's a job that I really enjoy, to try to bring back manufacturing any way that I can and help different agencies from the government. And at some point, also after 10 years at Siemens, got bitten by this startup bug that goes around Silicon Valley and decided to try my luck in the startup world and join Ready Robotics as their VP of product. Then opportunity came to join another rockets that was a startup that was growing very fast, Rapid Robotics. And we can talk about this robot-as-a-service, this Android for robots that we were doing at Ready later. And then 2 years ago, actually, time flies, they decided to be the crazy founder. And together with my co-founder, Carlos, we founded Reshape. And we founded it. A lot of people say, I founded this company out of love. We did it out of hate, out of hate of the two numbers, right? The one was 30,000, another one was 700,000. And 30,000 is the amount of robots on average that we deploy every year in the US. This number is 400,000 in China, by the way. And 700,000 was back then the amount of job openings in manufacturing. So if robots were stealing jobs, they were doing a very bad job on doing that. So it was a very illiquid market. There are a lot of automation vendors, a lot of opportunities for automation, as you can tell by the job openings, but not enough, very illiquid, not enough transactions. So that's why we decided to start Reshape, and we are in this 2-year journey. We are around, I think, 19 to 20 people now in the US and the Americas, and it continues growing and helping. Right now, when we started, was a little bit more into the manufacturer and the operator side of things. Now we shifted even more into the vendor side of the equation, because that's where we identify that we can make a bigger impact.
Amazing. Well, thank you for walking through that. I think that really helps set the stage. It's interesting you mentioned that data around kind of China versus US robotics deployment. Interestingly enough, or coincidentally, I was looking at some of that data earlier. And not only is the sort of quantum of robots already much larger in China, but the growth rate at which they deploy new ones is substantially higher. I think last year they grew about 275% roughly. The US only added about 37%. And so we continue to remain behind the curve from that perspective, and appreciate that you're tackling that problem. You also mentioned robotics as a service, and I'd love to kind of jump into that topic and get your perspective there. Given your experience, what works in robotics as a service, what doesn't, what should both manufacturers and founders be thinking about?
Mm-hmm. So I think in theory, it is a very appealing concept. But people usually misinterpret what does it mean and only get one part of it. So it's the service aspect of that is not only the financial model, but what happens after you deploy. And that's very interesting, right? If you just look into the financial, right, part of it, the challenge, and that was the same challenge that Ready had when they started. Right? Ready Robotics was also a robot-as-a-service company when they started. And the challenge that they had was that in this country, 98.6% of companies are SMEs. And a lot of them don't have great credit. So they were mostly appealing, this business model was mostly appealing for the companies that had bad credit, because obviously for them that was a way to finance their CapEx. And if you had good credit, CapEx usually makes sense, because that's you will end up paying less, and the total cost of ownership may be less for you. Now, but the second part of the robot service, that's where a lot of value actually comes. That is what happens after you deploy. And this is, again, this total cost of ownership. If something fails, do you still can go back to your integrator? How much are they gonna charge you for that? Versus in a robot as a service that you have guaranteed performance, and if something doesn't work, then you don't have typically that you don't have the associated cost with that. So you can treat that, if you want, as an employee, the same way that you handle an employee. So that's very appealing, because at that point in time, you are reducing your risk. And this is all about reducing your risk of implementing a new technology. The second challenge there is from the point of view of the companies offering robots as a service, right? So from the point of view of the operator, the manufacturer, the warehouse, even if financially may make more sense sometimes to own it, if you think about it, particularly if you're an SME entering into this world, your risk is high, may make sense to have someone to reduce that risk profile. But from the vendor point of view, the challenge is that robots are not just plug and play. It's not like I am buying a car, I give you the keys, it just works. There is a very tight connection between the process and automation. These two things come hand by hand. So a lot of times, particularly with SMEs that are starting, when you add automation, it's like your clothes are off. Like you are showing who you truly are and how good your processes are and how much do your human labor compensate. So if you are adding automation to a suboptimal process, it's going to highlight the suboptimalities. you're going to see things like you have a visual inspection system and you're going to say, oh, I don't even know if this part is good or not. Like a person was trying to figure it out and I never really spent the time. Or my parts, I thought that all my boxes were the same dimensions. They are not, because now the robot is crossing into them. And there are many examples. So, but when you optimize your process first, then automation actually highlights the efficiencies. And so the reason I said that is that now, imagine you are a vendor of robot-as-a-service. So it's still a very consultative process, because you need to help them not only saying, okay, you can automate that process, but typically processes don't work in isolation. So you need to think about the entire value chain of where this robot is going to connect to, and help them with sometimes optimizing their processes. So the sales cycle gets much longer. And the consequence of that is that a lot of tasks that are one-off, right? Every manufacturer is different, are very hard to fit with this model, because you spend a lot of time with that specific customer to understand their processes, to help them for just selling one robot maybe or two. And so what you see in companies that are more successful today with robots-as-a-service, like Formic, is they chose tasks that are more repetitive, like end of line, for example, palletizing or case packing. There is more repeatability between processes, which enables them to, okay, I don't need to understand everything. At the end of line, a box is a box. The moment that I am handling boxes, then I know that I can repeat from one to another. So my sales cycles get reduced. And what I'm offering to you is this reducing the risk.
Really appreciate you walking through that. You talked about how, depending on who you are, maybe the size of company, what you're building, robotics as a service can be a bit of a barrier unlock because it reduces your upfront capital requirements. What else do you consider sort of key barriers to robotic adoption?
Mm-hmm. The biggest one is that a lot of manufacturers particularly in this country, right? China's a little bit different because the subsidies are just, it's a different game. They can subsidize and take risk, and that risk is taken by the state. And for them, manufacturing is top priority, right? So they can infuse the amount of capital and kind of magnets to align the entire value chain that they have. It's very interesting to see also, just as a side note, the statistic that you mentioned, how they are growing with robotics, but they are not growing in data centers, for example. Mm-hmm. They're all about, in this country now, building data centers for AI. For them is, if we have to do it, we will do it. But right now, still is pumping into our industrials. So back to the US, big portion of SMEs, they have tons of problems, not just one. And automation is probably, and robotics, not one of the top. And after COVID or during COVID, something very interesting happened, right? That labor was not available. And so there was a surge in automation, particularly in warehousing. Like everybody was at home, everybody was ordering like crazy. And we thought that was the new normal. Labor was not there. So there was a lot of optimism. Okay, now is the time, like this new curve, the curve, as you see, it was like pretty linear, and we saw exponential. We thought, okay, this is going to be an exponential adoption. But the reality is that it kind of reverted back to the mean, and we are stuck with this 30,000 robots a year number that I mentioned above before. One of the reasons is that humans are going back to labor. So that labor problem is not that acute anymore, at least for labor like pick and place, right? More technical kind of work like machinists, welders, there's still a big gap, right? But back to your question on, okay, what is the biggest roadblock for adoption? One is that humans are very good. Like we are very flexible. And then second thing is a lot of plant managers and operators, they know how to fire a person. They don't know how to fire a robot, right? And if you are not performing, if you show up late, you're out, right? And I replace you, or I can coach you, but how do I do that with a robot, right? They see it as this big investment of hard investment in capital that with a big risk profile. And what I said before applies, right? Like if I have it and I don't modify anything else on how I am doing things, then it's going to be a disaster. And there are so many factories out there where I'm visiting them that they have this kind of corner full of robots, and the graveyard of robots, right? And this is because they tried and they failed. I bought this cobot, I'm going to automate myself. No, it's moving a robot is the easiest thing. Automating a process is the hardest part because there's so many interrelated things and so many unknowns. So it's a lot of work, in summary. Right? It's not a project that you do on a weekend, and they already most of them are fighting to keep now with tariffs and other macro, they are fighting to keep their doors open. So automation seems, okay, this is another project on top and a lot of work. The way that we tackle this problem, right, this realization is they need expertise. They need people to take them by the hand. They need people to understand their processes that are local to them, that they can be at their shop floor on a call and really understand and be a partner, right? They need partners that take that off their chest. Otherwise, it's a big weight. They're not going to be able to lift it alone. And what we realized is that was a very interesting bifurcation in the road at Reshape when we realized, okay, what do? Are we the ones actually on the shop floor with them, helping them with every single process to automate? We could, but that would mean that we need to cover the entire US. And as you see my map behind, that's a big country. Or we help the vendors, the people that are local, the integrators that do an amazing job, the OEMs, the distributors, free their time so they can be more time at the shop floor. And that's the road that we took, is from all the time that expert in automation have. I don't want you to spend 50% of your time in back office job. I want that you spend most of your time with your customer, helping them. And then all the quote, the preparation, the finding the right SKU, we do it for you with our agents. So that's the bet that we are making. How we are helping reindustrializing is giving superpowers to this part of the equation, very important part that are the vendors, so they can really help local and with the problems that manufacturers have.
Within this topic of reindustrialization, I think there's technology which has gotten a lot of press, and I'd love to touch on that given one of the comments you made in there around humans are just better at doing a lot of this stuff, that we have opposable thumbs, we have flexibility in our limbs, etc. And so with humanoids, I'd be curious your perspective on where they practically fit into kind of the industrial automation context today versus what are they lacking? What's just hype at this point?
Mm-hmm. Very interesting topic and not controversial at all. If you see to your point, humans are extremely dexterous too. Like our hands, there is a nice figure people can search online where a human is represented proportionally to their sensing capabilities. And hands are huge, lips are huge, and other parts of the body, but the hands are, if our hands were proportional to our sensing, they were huge. And I think that's the biggest right now roadblock is our dexterity and our autonomy. And when I see humanoids dancing, doing jumps, moving like humans, that's more of, even though it's an extremely complex problem, it's more of a solved problem. And I'm more optimistic in the short term that for humanoid-like robots to do more entertainment, because that's what you need, right? And you see this cute Frozen, the Olaf robot from Disney. That's a great application. And I want to see more robots when I go to Disney, right? Entertainment is something that near term makes sense. But everything that requires dexterity, there hasn't been really a leap. And there hasn't been this ChatGPT moment for robots at all. And there are very, very interesting companies like Physical Intelligence doing work with reinforcement learning and other approaches and VLMs and other approaches to robotics. But still in their infancy and doing tasks that doesn't require that level of dexterity. And that's the biggest gap, right? If we are serious about doing tasks that humans do, we are extremely dexterous and extremely autonomous. We can think outside the box if something is not what it used to be. And just to put you an example, when we were working on a bin picking project for supermarket, and one of my previous companies, and we were handling all kinds of products because these are robots that handle your groceries. So you can order everything. It can be a bag of nuts or it can be bananas. And one of these items was milk. And milk sometimes is not well screwed. So the bottle of milk that we were handling was open. The robot didn't know, just grasp it, put it in a bag, everything full of milk. You wanna get one of the hardest tasks is removing milk from any piece of equipment. So that's a funny deployment that I will never forget. But to the point of a human will know and stop. How will the robot know that the milk is spilled? Eventually, we can have loops that recognize that things are not normal, but when everything is new and everything changes, the definition of normal is hard to get in rules. It is, but for a human, it just is natural, right? And I think that's also the getting a little bit philosophical, the difference between nature and nurture. Like when I pronounce them, they are the same, but they're different things, right? Like on nature, physics, everything that comes like in our hardware, that comes by default. There hasn't been a fundamental technology that has changed or the way that we incorporate this nature, this physics into our processes, right? What you see in LLMs is also the nurture, is the language, what we learn, right? That we as humans, we think that, language is the greatest invention here. But the reality is that we use a defined set of words in a specific order, and that turned out to be a very good application for transformers and LLMs. So, but back to your question, to humanoids, it's very hard still to replicate our hands. They have been evolved through millions of years. What I will see, and I also find funny that people with humanoids, they started with factories as, this, because it's just like a replacement of labor that seems obvious. The reality is that in manufacturing, you need this 99.99% of precision that makes it extremely hard. So what you're seeing in some companies now is either targeting or pivoting into homes, which is also very hard. Like, I think there is something in the middle. There is like construction where there is still gonna be humans, but you need to go over the stairs and you're moving things from one place to another, but probably don't require the same dexterity. Hospitality, as I said, places where dexterity is not such a problem, and locomotion and basic navigation will solve, and then language to communicate with humans will be enough to solve the use case. I'm optimistic about those. Seeing them in manufacturing, it's for meaningful tasks. I would say probably in 10 years, right? And I'm probably optimistic. But there will be like companies like Tesla that control more, and they also are producing their own Optimus, and then maybe they may have a leap there because they can adapt their processes to that. But if you think about also the problem, like from first principles, like the most optimal factory doesn't really have humans, right? It's fully lights out, all automation, the underhyped, good old-fashioned industrial automation running everything. So the fact that you are running, the fact that you are humans, that's the bug in the equation, right? You need them because you cannot achieve that flexibility. But the form factor of a human is not ideal. Like we cannot lift heavy weights. So why aren't we? We are not that fast. So maybe it makes sense that a humanoid has wheels. Maybe it makes sense that they have different torsos. And on the other side, when you work alongside humans, what the humanoid gives you is that level of um, relatedness, right? Like I am related to, it looks like me, right? And that kind of solves some of the fears that we have with biggest intimidating robot arms. But back to your question, where do I see them? Right, summarizing a little bit this this rant on humanoids is definitely there is a hype that is not helping the entire robotics industry as a whole, because if that bubble explodes, there are consequences, and also it's not fair to, when people think about robotics, only think about humanoids now. I'm optimistic that there are areas where they will make a attempt in some tasks where dexterity is not that required. Also, even elderly care, like just being there and helping you helping you remember things, but giving you that humanoid form that makes it less scary. Um, but also not afraid about definitely not afraid about a world where they completely take over and that there are like trillions of them and they cost 5K. No, I think it's gonna take time, and it's very similar to what autonomous cars were in 2010, right? So I think the same analogy, it will take time. There will be companies like Waymo waiting and doing things well. There will be companies rushing and then having to close because some accident, right? There is not a these things wait, right? And if they don't have batteries, they just fall. So there is no safety standard right now for humanoids, which is also will be a big need. And there will be cities like San Francisco, like the equivalent of San Francisco in a factory, with tons of them, and there will be the equivalent of driving in Rome that is complicated and it will not happen autonomously anytime soon. And the same thing with some factories, they will not see any humanoids in their life.
Well, I'm glad to hear you don't foresee a humanoid takeover. That's
Well,
comforting. I did want to switch gears and ask you a little bit about AI. You know, you're building an agentic platform, and you've made comments in the past about sort of the difference between generic copilots versus kind of deterministic domain expertise based agents. Could you walk us through why that difference is important?
yeah, I think it touches a little bit this nature nurture difference that I was mentioning before, on particularly on language, right? It's very easy for humans to confuse efficiency with competence, right? And if we hear someone very eloquently speaking and describing a concept, we'll say, okay, this person is clever. There is intelligence in the back, because the way that he chooses the words, or the way that he explains a concept, transmits or directly correlates with his intelligence. So efficiency and competence are correlated. It's not the same in AI, right? When you go to ChatGPT, it's extremely efficient. It may be not competent in some fields. Obviously, it is an incredible technology, right? I think right now there are like two camps. Either you think we are going to get AGI tomorrow, or LLMs suck and they are the worst invention in the world. And I don't think neither are fully true. I think it's okay to, in your mind, think the current technology, like LLMs and transformers, will not get us to AGI. There are fundamental limitations on their understanding of the physics of the world and the world model that humans don't have. Like we have a lot of intuition, physical intuition, that LLMs, just by reasoning on the language, seems they have, but they don't. And but there could be another paradigm that brings us there. And at the same time thinking, but this technology is so amazing that we just scratch the surface and it will unlock an incredible boom, economic boom, just with the technology we have today. Like if we stop and the models don't get any better, we will have tons of startups to be made, tons of business to revolutionize, because it fundamentally changes the way that we did software and that we communicate. Like traditionally, there was a division between the technology and who could use it. You need to learn how to use it, right? If we were even to the previous generations of AI, deep learning, you need to know what you were doing, right? You need to train some images, say which ones are good, which ones are bad, and then you will train an algorithm that will deliver a result. With LLMs, the language is your interface, which is incredible, right? This is basically a way to compress the entire internet into a language UI where you can customize every question and answer. This is incredible by definition. And then it has another very interesting side effect, if you want, and it's that you can reason on unstructured data because this is very good. Languages, different languages is also, there's some level of unstructuredness. Data also can be unstructured. So these rigid data models that were also going back to warehouse and supply chain, there were a lot of projects where we wanted to connect data from the field to data from different systems. And it was always hard because it's like a monumental task that you need to define one single data structure. And now with AI, with LLMs, you can have completely unstructured data and reason and use the tools that really make sense for you. So when we go to an integrator or even a factory or a warehouse, and we see that they run their businesses on Excel, we don't tell them, hey, remove Excel. We are the ones saying, keep using Excel. Like, we are just going to empower and give you the data that you need and make sure that you have the right data. But if this is the tool that you use, keep using it. So back to what LLMs are, I think this technology is incredible. And it's incredible for the things that are the same thing with humanoids. There are some strengths and some things that still are not there, like the dexterity. And in this case, interpreting language, this is incredible. Back to my previous comment, it gives everybody a UI that you know since you are 2-year-old, right? Which is speaking or writing. Now, the next thing is, but there are things that is not good, and it's that determinism, right? If you are asking the same question, you will get different answers. And in my world, for example, what does it mean, right? If we are creating an agent for, let's say, a distributor, industrial distributor, and you go to their website and you start interacting with the agent and describe your problem and suggest a bill of materials, these things you cannot return. It's like Amazon that I suggest a new t-shirt and I thought I was an M t-shirt and you gave me an L. I will return it. This is, you cannot return it, or worse, you install it, it doesn't work. So it erodes the trust in the brand the moment that they do that. So we have to be, that's the other thing, like humans are also not 99.9% precise, but at this point in time, that's the mark that we have established ourselves. Like we have to, it's okay to 1 every 1,000 give a kind of an incomplete answer, but most of them consistently have to be correct. How do we do that? Right. So it's not just a wrapper around ChatGPT or any other LLMs. The models are great and they help greatly. And we combine all sorts of models because each one has its own strengths. But when it comes to the determinism, it's a lot of logic, code, guardrail, everything that goes around context engineering. That is much more than just prompt engineering. The prompt is one aspect, but you have to infuse these ontologies, this physics of how things work in the way that you program the agent, so it becomes deterministic. So when you are configuring a servo motor, you know the components and you know what goes into that. Like friction is important. How do you handle all those meta parameters? And also when it goes down to selecting the right product, that process becomes deterministic. So if you see our agents from the back, we use our own no-code, low-code interface to program them. And that's how we are very fast in programming them. But these are like thousands sometimes or hundreds of boxes and it looks like a spaghetti of connections. But inside each box, there is a deterministic configurator that at the end of the day, if you ask the same question, it will provide the same answer. And I think this is the combination of the two that is really powerful. When I go back to my previous life, when I was doing AI for robots and not for humans, it was kind of the same. Like I remember a paper that we wrote with some professors in Berkeley called Residual Reinforcement Learning, which was going back to the concept of mixing good old-fashioned control models that are deterministic with reinforcement learning where it makes sense. So if I am moving in free space, probably I can still do the same control policies that I have been using traditionally. But when I'm touching an object, that's where reinforcement learning can help. So this thing, the mix of the two. And the same thing happens with our agents. If I want to interpret what you're saying, I'm going to use an LLM. But we don't foresee models getting into this level of determinism without logic.
That makes a lot of sense. And I think it's the perfect point to bring us home. Juan, thank you so much for joining us and for sharing your perspectives. To our listeners, thank you again for tuning in. We'll catch you next time.
Thank you. It's been a pleasure to be here.
Thanks for listening. If you enjoyed this episode, leave us a 5-star review and tell us what you liked. And be sure to head over to podcast.dynamo.vc to keep up to date with our latest content or subscribe on the podcast platform of your choice. Until next time.